In this video, we're going to work example problems where we solve equations by first analyzing the equation and seeing that if we make a substitution, so we say that a new variable is equal to some variable expression within the equation, we can convert the equation to a form that we are already familiar with. In this case, we're going to be converting all these equations to quadratic equations, but really you can extend this principle to any kind of equation that you want to keep this idea, this technique in mind, throughout math. That if you can make a variable substitution, a new variable substituting for some variable expression in some equation or expression, you can convert it to a simpler form that you're familiar with, whether it be a certain type of equation or whatever. So yes, we're only going to be converting these to quadratic equations, but it's important to realize that you can use this technique in all kinds of scenarios throughout math. So, okay, for example, here, let's solve this equation. Well, we could expand everything out here, and it looks like what we'll have is a quadratic, and we can combine like terms, get the quadratic equation, and then solve the quadratic like we're already familiar with. But if you notice here that if we said that u was equal to 2x plus 5, then we could make this a lot easier. But in some situations, without making a substitution, you won't be able to solve the problem. There might be integrals or derivatives or other equations to where if you don't recognize the substitution, you can't even solve it. In this case, it looks like we could solve this if we just expand everything out and combine like terms. But in other circumstances, without the substitution, you can't solve it, or it would be significantly harder without the substitution. So, okay, but if we say that u is equal to 2x plus 5, then what do we get? We get u squared minus 7u minus 30 is equal to 0. So there we go. That's just a standard quadratic equation. Now let's go ahead and solve this for u. So let's see. 6 times 5 is 30. So let's see. Let's keep going. So minus 3 times 2 times 5. So it looks like we can't factor this. So let's just go ahead and use the quadratic formula. So, okay, b squared minus 4 times a times c all over 2a, okay? So 30 times 4 is 120. 120 plus 49, 169. So we've got 7. Okay, so the principal square root of 169 is 13. Okay, so u is equal to 13 plus 7 is 20. 20 divided by 2 is 10. And u is equal to 7 minus 13 is minus 6. Minus 6 divided by 2 is minus 3. Okay, so now, but we know that u is equal to 2x plus 5. So subtract 5 from both sides. So x is equal to 5 halves. Okay. Let's see. Now we've got 2x plus 5 is equal to minus 3. So minus 3 minus 5 is minus 8. So x is equal to minus 4. Okay, and that's going to be the two solutions, assuming we didn't make any math errors. We don't have to check these because this is just, everything we did was just related to solving a quadratic. Okay, so here we see that if we say that u is equal to x squared plus 2x, then we've got u squared minus 18u, and we could do plus 45 is equal to 0. Okay, so 45, 9 times 5 is 45, 3 times 3 times 5. So, okay, 15 and 3 add to 18, so we can do, let's see, 15. Okay, so minus 15 minus 3 is minus 18. 15 minus 15 times minus 3 is positive 45. So there we go. So u is equal to 15, and u is equal to 3. Okay. So let me put this off to the side here. So u, all right, so now, but u is equal to x squared plus 2x. So we've got x squared plus 2x is equal to 15. So x squared plus 2x minus 15 is equal to 0. So we've got okay, so plus 5 minus 3. So x is equal to minus 5 and x is equal to 3. That's two solutions, assuming we didn't make any math errors. Okay, now what about x squared plus 2x is equal to 3? So you've got x squared plus 2x minus 3 is equal to 0. So x, 3, 1 plus 3 minus 1. So x is equal to minus 3 and x is equal to 1. There we go. Okay, we can see that, again, you see how useful this can be. But here, this is just quadratics, but just keep in mind that you could do this for any situation. There's so many situations in math where you can look at something and say, okay, I can make a variable substitution and put it into a simpler form that I'm already familiar with. If we said u is equal to x squared plus 2, then we've got u squared plus u minus 42 is equal to 0. 7 times 6 is 42. So we've got 7, 6. So plus 7 minus 6. So u is equal to minus 7 and u is equal to 6. So, okay, we've got x squared plus 2 is equal to minus 7. So x squared is equal to minus 7 minus 2 is minus 9. Square root of both sides, square root property. So x is equal to plus or minus 3i. Okay, now x squared plus 2 is equal to 6. So x squared is equal to 4. Square root property. So x is equal to plus or minus 2. Just like that. Okay, so you look at this and you think, well, what could we do with this? Well, all right, if we write it this way, I mean, we could solve this as a rational equation, right? This is a rational equation. We could solve it like a regular rational equation, and that would be fine. Okay, but it's important to practice. You want to practice. The whole purpose of this really is to practice this technique of recognizing these forms and these patterns. Yeah, in this scenario, why don't we'll just multiply the entire equation by a squared, solve. Why not do that? But if you practice this, recognizing these patterns, it'll be helpful in another scenario where it won't be so simple to just solve like it is. Okay, so now if we look at this, it's easier to see that we could say that u is equal to a to the minus 1. Therefore, what is u squared? A to the minus 1 squared is a to the minus 2. Okay, and so what that results in is you have minus 2u squared plus 4u plus 1 is equal to 0. Now we can add 2u squared to both sides, subtract 4u from both sides, and subtract 1 from both sides. Okay, now let's use the quadratic formula. So minus b plus or minus b squared minus 4 times a times minus 1. So we'll just put bring that minus to the front there, all over 2a. Okay, so we've got 4 plus or minus 16 plus 8 is going to be 24. Okay, now 6 times 4 is 24, so we can write that as 2 root square root of 6. Okay, now we can factor out a 2. Okay, and we're left with that u is equal to 2 plus or minus root 6 divided by 2. Okay, so now, but u is equal to a to the minus 1, or 1 over a. Okay, so let's go ahead and take the reciprocal of both sides, and we get, okay, but now let's rationalize this. So we want to do, so, okay, yeah, so this isn't too confusing. We've got a is equal to 2 plus root 6, and then 2 over that. So let's multiply this by 2 minus root 6 over 2 minus root 6, and we get what? So a is equal to, in the denominator, we're going to have 4 minus 6 is minus 2. In the numerator, we're going to have 2 times 2 minus root 6. So that's minus 2 plus root 6. Right? If we distribute that minus. Okay, now if we have a is equal to, the other case was this. So multiply this by 2 plus root 6 over 2 plus root 6. You're going to get what? 4 minus 6 again, minus 2, and then 2 times 2 plus root 6, you're going to get minus 2 minus root 6. And that is the two answers. None of those are 0. A can't be 0, but those aren't 0. Okay, so we can see that if we wanted to use substitution to solve this, we could do, okay, so if we said u is equal to n plus 2, this is to the minus 1, n plus 2 to the minus 1, then u squared is equal to n plus 2 to the minus 2. So we've got 2u squared minus 3u, and subtract 5 from both sides. Okay, so 2 times minus 5 is minus 10. Minus 5 times 2. Okay, so we can do 2u squared, and then let's do minus 2u, or no, plus 2u minus 5u minus 5 is equal to 0. Yeah, that's going to work. So now we can factor out a 2u, you've got u plus 1. We can factor out a minus 5, you've got u plus 1. Okay. There we go. So u is equal to 5/2, and u is equal to minus 1. Okay. So now, but u is equal to 1 over n plus 2. So 1 over n plus 2 is equal to 5/2. So let's cross multiply. You've got 2 is equal to 5n plus 10. Okay, so 5n is equal to 2 minus 10. So n is equal to minus 8/5. There we go. Okay, now, but do we need to consider any issues here? Well, it's just going to be dividing by zeros. It's minus 8/5. We're fine. Well, let's see. What can minus 8/5 plus 2 is what? So 2 is 5 times, so 10 over 5. So that's 2/5 squared. That's fine. So no issues there. Okay. So that's going to be a solution. If as long as we're not dividing by 0 with this, that's going to be a solution. So, okay, but now we've got 1 over n plus 2, u is equal to minus 1. So minus n minus 2 is equal to 1. Minus n is equal to 3, so n is equal to minus 3. Is that a dividing by 0 issue? No. Okay, here we see that we can say, if we say that u is equal to m minus 10 over m, then you've got u squared minus 6u minus 27 is equal to 0. Okay, so let's see. 9 times 3 is 27. So minus 9 plus 3, there we go. So u is equal to 9, and u is equal to minus 3. So, but u is equal to m minus 10 over m. Okay. And then so, all right, now let's multiply this. Here's a rational equation. Let's multiply this by m. So you have m squared minus 10 is equal to 9m. So m squared minus 9m minus 10 is equal to 0. So we've got, let's see, m 10, 1 minus 10 plus 1. So m is equal to 10 and m is equal to 1. And this is kind of weird. It's like, okay, well, what if we got something that one of these numbers wasn't a solution here? Does that mean it wouldn't be a solution in the in the original equation? Well, no, because this is an intermediate step. You would still just go. I mean, look, if you're not sure, just go plug it in, right? Like go plug it into the original equation and you'll see. But the general idea would be if for some reason you got a solution here that wasn't a solution to this rational equation, well, this isn't the original equation. This is an intermediate step. So you could still go ahead and say, well, look, it came out mathematically. I got this answer, so plug it back in. If it's a solution to the original equation, it's a solution. If you plug any number into the original equation, you simplify one side, you get a number. You simplify the other side, you get that same number. It's 100% a solution. I don't care what you did in the intermediate. Okay? So, but we can see we're not dividing by 0 here anywhere. So these are going to be two solutions. Just m can't be 0. Okay, now we've got m minus 10 over m is equal to minus 3. So let's do, we've got m squared minus 10 is equal to minus 3m. M squared plus 3m minus 10 is equal to 0. So what do we have? m 5, 2, okay, plus 5, okay. So m is equal to minus 5, and m is equal to 2. Okay, we can see that we could say that u is equal to 2 plus 3 over t. In that case, we've got u squared minus u, and then we can subtract 12 from both sides. Okay. So u for 3 minus 4 plus 3, so u is equal to 4, and u is equal to minus 3. Okay, so but we have 2 plus 3 over t, that's u is equal to 4. So, okay, 2t plus 3 is equal to 4t. Okay, subtract 2t from both sides. You have 2t is equal to 3, so t is equal to 3 halves. Okay, t just can't be 0, so that's going to be a solution, unless we made a math error. Okay, now 2 plus 3 over t is equal to minus 3, so we've got 2t plus 3 is equal to minus 3t. Add 3t to both sides. You get 5t. Subtract 3 from both sides. So t is equal to minus 3/5. Okay. So here we see that if we can say that u is equal to c to the 1/5. Okay, therefore u squared is equal to c to the 2/5. So we've got 5u squared minus 11u plus 2 is equal to 0. Okay, so let's see. 5 times 2 is 10. 10 times 1, so we can do 5u squared minus 10u minus u plus 2 is equal to 0. So we factor out a 5u here. You have u minus 2. Factor out a minus 1 here. You have u minus 2. Okay. 5u minus 1, u minus 2. Okay. Now u is equal to 1/5. U is equal to 2. Okay, so, but u is equal to c to the 1/5. All right, so now let's raise both sides to the power 5. And we've got c is equal to 1 over 5 to the 5th power. Okay, we only have 5th roots here. There's no domain issues or anything. We only raised both sides to the power 5, so we don't have to check the solution. Okay, now we've got 2 is equal to c to the 1/5. So raise both sides to the power 5, and we've got c is equal to 2 to the 5th. Okay, here we see that if we say that u is equal to y to the 1/4, then u squared is going to be equal to y to the 1/2, right? So u squared minus u minus 6 is equal to 0. So we've got u, 3, 2. So minus 3. Okay. So, okay, y to the 1/4 is equal to 3. So now we raise both sides to the power 4, and we've got y is equal to 3 to the power 4. Okay, now we still might not have to check this because all we need to do is check it. We raise both sides of this equation here to the 4th power, so you plug it back in. 3 to the 4th to the 1/4 is going to be equal to 3 to the 1st. So, but we can still check it. So 3 to the 4th power to the 1/2 is going to be 3 squared. Okay, now 3 to the 4th power to the 1/4 is going to be 3 to the 1st. So 9 minus 3 minus 6. 6 minus 6. Okay. So that's a solution. Now we've got y to the 1/4 is equal to minus 2. So we can raise both sides to the power 4, but this isn't going to work because there is no, so 2 to the 4th is 6, minus 2 to the 4th is 16, but if we plug it back in here, the 16 to the 1/4 is positive 2. But we can still go check it in the original equation, so because this equation here doesn't matter. It's really all about the original equation. So let's just plug it back into the original equation. So the principal square root of 16 is 4. The principal 4th root of 16 is 2. So 2 minus 6 is not equal to 0, so no. Right? You see what I mean? Like we still, even though we plugged it back into this, we just solved this radical equation, and it wasn't a solution. But we can still go ahead and plug it into the original equation just to check. All right, so here we can say that u is equal to y to the minus 2. Therefore, u squared is equal to y to the minus 4. So we've got 9u squared minus 10u plus 1 is equal to 0. Okay, so we can do, let's see, 9u squared minus 9u minus u plus 1. And now the grouping is going to work. So 9u, we learned all this. This is all we learned this all how to do this in the factoring sections. So we have u plus 1 minus, and then u minus 1. Okay. No, this is going to be u minus 1 over here. So, okay. Let's see. 9u minus 1, u minus 1. Okay, so let's see. U is 1/9. U is 1. Okay, but now let's see. Y to the minus 2 is equal to 1/9. So that's 1 over y squared is equal to 1/9. So y cross multiplying y squared is equal to 9. So y is equal to plus or minus 3. And there's no domain issues there, so that's going to be 2 solutions. Okay, now we've got 1 over y squared is equal to 1. So y squared is equal to 1. So y is equal to plus or minus 1. Those are going to be 2 solutions as well. Okay, here we can do, so if we say that u is equal to the square root of t, then u squared is equal to t. That's pretty clever substitution. So we have 4u squared minus 25u is equal to 0. So we can factor out a u, 4u minus 25. Okay, so we've got u is equal to 0 and u is equal to 25/4. Okay, but u is equal to root t. So we've got root t is equal to 0, so t is equal to 0 as a solution. Okay, and then we've got root t is equal to 25/4. So now we square both sides and we get t is equal to, so okay, 25 squared over 16. So 625 over 16. And if we plug that into the original equation here, that's going to be a solution. Square root of 625 is 25. Square root of 4, or square root of 16 is 4. So there we go. Okay, how can we make a substitution here? Well, let's see. So we've got x to the 4th plus 5x squared minus 7 is equal to 0. Well, that's how we would factor this. If we were asked to factor this, we would make the substitution that u is equal to x squared. Therefore, u squared is equal to x to the 4th. So you've got u squared plus 5u minus 7 is equal to 0. So, but, okay, we need to use the quadratic formula here. So u is equal to minus b plus or minus b squared minus 4 times 1 times minus 7. So 28. Okay, so u is equal to, let's see. Okay. So, but u is equal to x squared. So we've got, okay, now but we want to do the square root property. So we've got x is equal to minus 5 plus or minus root 53. Okay. And there we go. Okay, if we say that u is equal to k to the minus 1, u squared then is equal to k to the minus 2. So we've got 30 u squared minus 23u plus 2 is equal to 0. So 30 times 2 is 60. So we've got 15 times 2 times 2, 5 times 3 times 2 times 2. So, okay. 15 and 4, 6 and 10, 20 and 3. 20 and 3. So, yeah, this was, 20 and 3. So, okay, we can do 30u squared minus 3u minus 20u plus 2. Okay, so we've got 3u, then 10u minus 1. Okay, now we take out a 2. You've got 10u minus 1. And there we go. So 3u minus 2, 10u minus 1 is equal to 0. So u is equal to 2/3. U is equal to 1/10. So, okay, u is 1 over k. And then, okay, so 2k is equal to 3. K is equal to 3/2. Okay, now we've got 1 over k is equal to 1/10. So we could just take the reciprocal. So k is equal to 10.